In this video, I'm going to drive these rules of graphing the derivative. The rules for number 1 and 2, it's about when f of x is increasing or decreasing. For number 1, if f of x is increasing on the interval, then the derivative is positive on that interval. For part 2, if f of x is decreasing on the interval, f of prime of x is negative on that interval. And then for part 3 and 4, it's about the concavity of the function. If f of x concave up on the interval, f of prime of x is increasing, and then the second derivative is positive on that interval. Then for part 4, if f of x concave down on the interval, f of prime of x is decreasing, and double prime of f is negative on that interval. Before driving the rules of graphing the derivative, let's look into these graphs from A to D. A and B are both linear function. Notice at A, the function f of x is increasing and the slope is positive. For B, the function is decreasing and the slope is negative. Then for C and D, this is about the concavity. This is the shape of concaving up for C, and this is the shape of concaving down for D. Here are two functions of f of x. One is concaving up and the other is concaving down. I'm going to determine the behavior of the derivative using these two graphs. So let's look into the first graph. I'm going to split that into two segments, left or right. On the left side, we can notice that the function is decreasing, and on the right side, the function is increasing. Now let's determine the behavior of the derivative. Remember, the derivative is the rate of change and it is the slope. So I'm going to draw a tangent line to this curve and determine the sign of the slope. And the sign of the slope is going to be the sign of the derivative. So on the left side, the slope of this tangent line is negative. Therefore, the derivative here is negative. On the right side, the tangent line here is positive. That means the derivative on this side is going to be positive. And then in the middle, when I draw the tangent line, the slope is horizontal. This means the slope is 0, therefore the derivative there is 0. Notice on the whole interval here, the function f of x is concaving up. Notice here when f of x is decreasing, f of prime of x is negative. And then when f of x is increasing, f of prime of x is positive. Now let's look into the second function. I'm going to do the same. I'm going to split it into left and right. On the left segment, the function there is increasing, and then on the right, it's decreasing. Now let's determine the derivative. On the left side, we can notice the slope here is positive. Therefore, the derivative also going to be positive. And then on the right side, the slope of this tangent line is negative. Therefore, the derivative going to be negative. And then in the middle, slope is horizontal, which means slope is 0. Therefore, the derivative is 0. Here we can notice f of x is increasing, f of prime is positive, and then f of x is decreasing, f of prime is negative. And this is exactly the same thing we found from the left graph. And notice for the whole interval here, the function is concaving down. Here, if f of x concave up, then as we go from left to right, we can notice that the first derivative here, it's increasing. First it's negative, and then it's 0, and then it's positive. For the second graph, we can notice that f of x concaving down. And as we go from left to right, and we notice the first derivative, it's decreasing. Since first it's positive, and then 0, and then it's negative. Now let's look into the behavior of the second derivative. Remember that the second derivative is the derivative of the first one. So let's use first when f of x is increasing or decreasing. On the first graph, we can notice that we have graph concave up, then f of prime is increasing. Here, the second derivative gonna be positive because it will follow the same rules as when we have f of x and we want to graph f of prime of x. Here, when we have f of x is increasing, then f of prime is positive. That's gonna be the same for the second derivative. And then on the second graph, since f of prime is decreasing, the second derivative there is negative. Now, after we drive these rules, what we want to do is graph the derivative and the second derivative and see how these rules apply to the graphing. Here we have same as previously. These are the two graphs. We can notice we have the notation of the behavior of the first derivative on them. Also, I just put an axis on this graph of x and y of x. Now I'm going to draw the first derivative and then the second derivative. Then I'm going to check the rules we just derived. So here are the rules on the bottom that we just derived. Let's see and apply them. So for number one of f of x is increasing with the interval, f of prime of x is positive on that interval. So when we are looking into the function a, it's increasing when 0 to infinity. Therefore, the derivative is going to be above the x-axis on this section. And then for 2, f of x is decreasing on the interval, f of prime of x is negative on that interval. Here, f of x is decreasing on minus infinity to 0. Therefore, on this section, the derivative gonna be below the x-axis, going to be negative. And this, note here, the graph is concaving up, so I'm gonna move to 3. F of x concave up on the interval, f of prime of x is increasing, and then f double prime of x is positive on that interval. So we have two segments here. First, let's look into the first derivative. On the first derivative, we notice that since the function is concaving up, it's increasing in value. And then for the second derivative, we can notice it's above the x-axis, which means it's positive. Now let's move to part B. For 1, f of x is increasing on the interval, f of prime of x is positive on that interval. F of x is increasing from minus infinity to 0. Therefore, when drawing the first derivative, it should be above the x-axis, should be positive. And then for 2, f of x is decreasing on the interval, f of prime of x is negative on that interval. F of x is decreasing from 0 to infinity. Therefore, for this section, when we're drawing the derivative, it should be below the x-axis, it should be negative. Note in here, this function concave down, so I'm going to jump to step 4 or part 4 of f of x concave down, then f of prime of x is decreasing, and f double prime is negative. So we can see here for the first derivative, it's decreasing in value. And then for the second derivative here, we can notice the graph, it's below the x-axis, it's negative. So all these rules satisfies the graphing the derivatives.